Hi, this is Ed with Weed Electric. Today I'm going to talk about a three-phase conventional motor starter and its effects on your operation. Now, ultimately, we all know that downtime is the number one enemy of a clean, efficient operation, and that ultimately, whenever you have your downtime reduced, that you can expect your operating costs to be down and your profit to go up. And that's what the game of manufacturing is all about, and we know that. But one of the key components is always, in reducing downtime, and it's as much of an art as it is a science. There is definitely a science to tracking downtime and to eliminating the biggest hitters for you. But one of the things that gets overlooked oftentimes is a motor starter. We go out and we PM, we lube, we do belt tensioning, we do a ton of things that will continue to make the equipment operate as it should. But one of the things that gets overlooked oftentimes until the equipment is down is your motor starter. And I'm going to, let me see, I've got a couple of them here. This is just a typical three-phase conventional motor starter. This one is a size 0, and it is good for 5 horse at 480. At three-phase 480, you can run a 5 horsepower motor on this. So the main components of this are, and this one's a square D, and they're all very similar. I will show you the differences. This is a NEMA style motor starter, as you can see, and this is a good style. And there are many other styles. This particular one right here, even though it's smaller, if you can see, this is an IEC version of a motor starter. This one is actually good for 20 horsepower motor, even though it's smaller than this one. So you can see the trade-off in size. A lot of original equipment manufacturers will ship equipment with this, with a IEC rated motor starter, because they are a little cheaper and they also take up less space. And that's good on the front end cost, but sometimes whenever you have a piece of equipment that you really rely on, and just in my experience, the IECs they're not as robust as the NEMA style. You can tell it's a bigger component to do the same job, even though this one actually does a smaller motor than this one does. However, this guy right here, the NEMA motor starters, they are built, like I say, fairly robust. It's very serviceable, and I actually am going to take this apart here in just a little while and show you some of the internal components that are serviceable. So, and this right now, whenever an electrician or someone talks about a motor starter, this is the actual component that is a motor starter, and then this part beneath, and this is an old style, this is a heater style, which there's still a ton of them out there. This is an overload relay, and these two things have different components. They have different functions actually. So, as a motor starter, this part is nothing more than it's a glorified switch. In this case, the incoming power comes on the line side up here, and it goes through the internal components and comes out down here, and before it goes through the overload relay, which I'll talk about in a moment. I have one opened up right here. That is, okay, if you'll look here, this one, okay, this particular one was set up for a single phase application, but it's configured that it could operate a three phase. If you see where I talked about earlier, where the power comes in on the line side, it comes into these little contacts that are inside there. Let me see if I can get that so that you guys can see. Yeah, right up in there, there's a contact there, and then there's an adjacent contact here. The electricity, or the power, whenever it comes in, has to be jumped over to here, and that's done through these contacts here. Let me see if I can get that. Yeah, if you look, these are little contacts that will bridge the gap between the upper and the lower side. So whenever this is energized, this is essentially an electromagnet. There's a coil in here that's an electromagnet that overcomes a spring pressure to push the contacts together so that it bridges this gap here. So, and these contacts on a NEMA starter are completely serviceable. There's a screw in there that you take loose, and whenever you buy a contact kit, it'll come with the 2 of these and 1 of these for each pole, and that's so you buy a set of 3 to do that. But as you can see here, and I'll operate this for you so you can kind of get an idea, a little better visual here on what it does. Whenever the contactor is energized, what happens is, let me see if I can do it here. You can see that this part moves out. There's a spring in there that you have to the electromagnet will overcome that spring pressure and put this out, bridging this gap here. And that's what actually turns your motor on, or passes the power through the starter to the overload relay before it goes to the motor itself. So talking about the coil, the thing that actually energizes the electromagnetic portion of that, I have one of these here. This is another completely serviceable part that happens, and let's see, you can see that's it. There's all it is a coil of wire that's encased in an epoxy inside of this thing that creates an electromagnet that overcomes spring pressure to push the contacts together. The reason why I bring all that up is because oftentimes you'll have an electrician, electrical contractor, maintenance guy, whoever tell you, oh, we got a bad starter, we have to replace the starter. And that may or may not be true. Many times, if depending on what the nature of the failure is, it could be true. However, the internal components of that are completely serviceable, and if a guy's familiar enough with it, it's made in such a way that you can take it apart, clear it up, clean it up, and then put it back together. New parts, new components. Sometimes you can even dress up the old components to get you through in a pinch till you get a new set of contacts, for instance. Whenever you do that, the motor starter it's very robust. These guys right here, like I say, they're very popular with manufacturers because they're cheaper to buy up front. They do a larger a motor for the same value of space. However, there's a large portion of these that are not serviceable. So if you have a set of contacts go bad, you got to toss it away and put a new one in. It's not always the case, but it's not uncommon for smaller sizes to just be disposable. So, and like I say, it works out good on the front end for the manufacturer because they're selling you a functional piece of equipment. However, that functional piece of equipment may not last as long, or at least this part, because it'll last through their warranty period. However, after that, it's your baby, so to speak. So, oftentimes, whenever you have that a piece of equipment fail, these are shipped a lot on, let's say, like a Quincy air compressor, or just a ton of other pieces of equipment. They'll have these in there, and sometimes due to the vibration in an industrial environment, the vibration, the weather, a lot of other factors, you'll have premature failure with the IEC rated starter. And what we'll often recommend, it depends on the piece of equipment. Sometimes it's not a very abused piece of equipment, used every now and again. It's fine to use an IEC, but if it's something that's one of your key, critical components, upgrading to a NEMA-sized starter is a great idea in your in-house there. So, okay, now, and moving down through the starter itself, again, the serviceable components of it are contacts, which we looked at inside. Those are completely serviceable. And this one you can actually see. Let's see if I can get up there close. Okay, yeah. This one right here. This one right here is burned away. The contact. I'm sorry, this is a little blurry here. These little bars have a contact pad, a solder pad on top of those, and sometimes those will burn away, which you can see if you look real close. This one is burned up. So that does happen, and that's something that can be actually prevented if you'll have your maintenance guys or someone come in and do either an annual inspection, or depending on the use of the equipment, how often it's actually used, started, ran, how hard it's being used. It could be that there is you can catch it in time. So if you plan an annual outage, you can go through there, or on down days, and replace your contacts annually, or possibly more. I know at one location I had a chain conveyor which used it took 4x8 sheets of plywood and conveyed them across to a paint booth. And that particular conveyor, the motor horsepower was rated very closely to the load that it was doing. So those contacts would actually burn up. I don't remember the exact frequency, but it was about every 9 months or so. So we just got into a habit of a preventive maintenance for replacing those contacts at a 6-month interval. So. And then moving on to the overload relay. Let's see. The overload relay down here, this portion, and again, it's this portion right here. The overload relay, its primary purpose is to protect the motor. The motor starter doesn't care about the motor. All it's doing is passing power. Like I say, it's a glorified switch. But the overload relay itself is sized, has the, in this case, the old style heater elements are there. And then in the new style, this is a different manufacturer, different style, but this is a solid state overload relay. Here's a different one. This is a solid state overload relay, and these two things do the exact same thing. This one, you'll notice, doesn't have these little pieces in here. This is a heater element. This is a solid state, and you can take this little dial and and move it to match your motor full load current. And that's the intention behind this. So sometimes you may upgrade from a, I don't know, let's say from a 3/4 horse motor to a 1 horsepower motor, and on this you just spin the dial because it'll handle up to a certain horsepower range. These right here are very specifically sized. Let me get you up close, see if you can see the numbers. Yeah, there's numbers B25s there. The B25s, and there's a chart for actually sizing this. Every manufacturer has one. These may be set to, they're set to some amperage range, and let's just say one heater style may be good for 1.8 amps to 2.2 amps, and the next one might be good for 2 amps to 2.5 amps or whatever. So if you change the horsepower of the motor, you have to change the overload relay or the heater elements themselves. And these are prone to failure. They do fail from time to time. Not nearly as often as what electricians will tell you. Oh, they got bad heaters, and they'll replace the heaters. Oftentimes that's not the case, but it is. The guys do what they know, or what they've seen. So there's that. And this is a closer up look at this old style heater element here. Let's see here. This is the same type thing. If you look, there's a gear that's attached to a rod that's inside of a sleeve, and there's actually, the way this works, there's a solder type material that's inside of here, and whenever it's at room temperature or less than its rated temperature, this thing is actually, is frozen. It will not turn. But whenever it gets hot enough, as current passes through this, it's very specifically sized. Whenever it passes through here, it generates heat, and when it generates heat, the solder will loosen, and as the solder loosens and becomes fluid, you will have movement of this. And there's a little ratchet and pawl type assembly. Let's see here. I can show you on this one. These are mounted inside the overload relay. I'm gonna just put a little bit of pressure on this guy, and it snaps up. I don't know. And then now the motor won't run because it breaks the control circuitry for the electromagnet for the coil here. So that's how that works. Whenever too much current passes through these things, then it generates heat. The heat liquefies the solder, and the little thing spins based off of a spring pressure, and it'll open the circuit, basically creating an open circuit for your motor so that it protects the motor, allows it a chance to cool down. So there are a lot of tips and tricks when it comes to motor starters, a lot of different things for different manufacturers, but I hope you got a little something out of this today, and just a real basic, this is a motor starter and overload relay. If you like more information like this, then make sure to drop your email down below, and I put these out from time to time. So take care, and God bless.